Hello guys, myself Nikhil Mattani and my group members are Nikhil, Nitin, Ronak and Gaurav, and we are discussing about the new topic which is introduction to graphics software. Basically what is graphics software is a open software uh, graph visualization software. So it is a way of representing structural information in the form of diagrams and abstract graphs and also in the form of networks. So it has an important application in networking and also in the form of information, database and web designing. So now let's come to about the features of the graphics software. It can take description of software in a simple text language and makes the diagram in a useful format, such as we can say images and PDFs, postscripts, and for another documents also, which can display in a graph browser. While it has many features such as color font, tabular, line styles, hyperlink, and custom shape. Now I will be telling about what is data flow diagram. It is a diagrammatical representation of information flow within a system by what we can change the information or where we can save the information or store the information, we can say. However, information where enters or leaves the systems, and it has some basic advantages of modeling, which are adaptability, presentation, decision building. uh, First we can say organization. It helps to keep the program organized, while decision building tells about the how to help the programming figuring out, and about the options we need to handle the data which is given there, while error detection helps in debugging of the logic, while adaptability tells about how to make the flexibility of the programmer to inject new code. And there are different notations given in the data flow graph, which are the function, file, input, output and flow. Now I will be dealing with FSM, which is a finite state machine. Finite state machine is simply a state machine where we can say that a mathematical model of computation used for the design computer program. It has basically two categories, which is the milli and more. The basic difference between them is milli depends on only the one state, while more deals depends on the only one state, while milli deals with both input and the state. While as I have explained the detail about the application, while further working will be given by the Ron.
Hello guys, I am Ronak Rathod and I am going to explain you about the working of this software. So this software is already open. So this is a file. From here we can get the new file, which it's just exists over here. There is open, this save file and save as option. Then it's edit option where you can cut, copy, paste. There is a window in which you can work in tile form, cascade form. You can go to next window, work there, come back to previous window, like that. There is one graph, that option in that settings. You can go there and you can work there over here. It's a layout, and we are working on the dot script. So in this we are going to use this dot language, and this one is the output file in which we want the images file. You can have PNG, JPG, like that forms. So this is the layout which will run the script and will get the output in the graphical form. So we'll start with just one simple program. We'll write digraph first, then we'll have curly brackets, then we have to define the node. So we'll just give a, and if you want to give the shape of this node, we can give as many different shapes are available in this software, like box, polygon, ellipse, triangle, egg, diamond shape, trapezium. Now we'll go with the box. We'll give shape equals box. After this we have to give the relation between the nodes. So we'll give A goes to B, B goes to C, C and we'll end our script here. So this is our just a basic example, and we'll now click here its layout. So see, we have got this, we gave this as a box shape. This is B, as by default it will take the ellipse shape. B is ellipse shape, C is there, A goes to B, B goes to C, and then again C goes to A. So this is the graph which we have got. Now we can see here, this A goes to B. We can give label also if you want to give. We'll just write label equals 1. Now we'll see. So this is the 1. We got the label over here as a 1. If you want to give label in every form, we'll give the label over there. We can give color also. So this is the color of the edge. There is 1. We can many colors are available which we can use in our for making the graph. These are the various shapes which we have got. These are the arrow types which we can use, and these are the color names, different color names which the software inbuilt has provided, and we can use different color names over there. Let's use this dark green over here. We'll check and we'll change the shape also.
What?
We'll take circle. So this is what we got. A is changed to circle, and the color which we gave dark green, it's changed to here dark green. So this is the basic example which we taught, and now we'll go to another program which I have already typed. Now we'll see in this. This is diagraph which we have given. This is of the size 4,4. So this is the output of the image that we'll get. Then this is the main. So this is the node will be main. In that we have given shape equal to box, so it will be the square shape. Then the main will go to parse. Okay, and then we have given weight equal to 8. So now what is weight? Weight is the degree of the constant of the edge. Okay, then parse will go to execute, then main will go to int, and in that we have given style equal to dotted. So what is this style? This style is define the edge, what type of edge you want to give. So we have given this dotted edge. Then main will go to cleanup, then execute will have two branches, one will be the make string and one will be the printf. Then init will go to make string, and with that that edge will have color red which we have defined over here. Now we'll go write main goes to printf. So for that we have given label equal to 100 times, and in what we have to write bold, so we have given here bold. Now the make string label we have given make a string, and we have provided /n, so it will just come to next slide. And for the last node which we have given here, we can change this, we can give it red color also. This is style equal to field. This is the last node which we'll give, and with shape is box, style is field, so color will be filled inside that and its color will be red. And another is execute, so execute will go to compare. Now we'll just see the what graph we get here. So this is the graph we get over here. Just we gave the main shape equal to box, so this is the shape, and this is the edge what we gave from main to init, and we gave that dotted style equal to dotted, so the edge we got dotted. This is a label 100 times, for which we provided color equal to red. So we have got red color over here. And for execute we provided two outputs from there. So one was printf and one was make a and slash and string. So we got string in the next line, and we gave another node from execute to compare. With that we gave the field and the color equal to red, and we wrote the edge equal to red. We can now also see the change. We can change also here. We can select any color over here. We'll select dark green. We'll see. So now this is changed to the dark green. Similarly, we can also change colors. We can make fancy graphs with this software. And thank you for listening. And now the further two examples are there that will be explained by my friend Nikhil and Gaurav. Thank you.
Hi everyone, now I will be telling about the signal flow graph. Before implementing a signal flow graph, we need to know the importance of signal flow graph and how they are used for in computer programming. Basically, what is signal flow graph? Signal flow graph is a mathematical modeling of the computer programming. For example, in the computer programming, if the data is flow from one process to another process, such can be represented in the signal flow graph in the form of various states. And the effect which causes from the transition from one state to another state will be directed from one state to another state in the form of transitions. Then what will be the advantages of representing the computer program in the form of signal programs? It provides an effective communication for the layman. If a programmer wants to convey the logic to some layman or some non-technical person the client place, then if he tries to explain the logic through computer programming, he cannot effectively communicate the logic. But if he conveys in the form of signal flow graph, which will be in the form of pictures, it will be effective communication. And one more, it serves as a proper documentation tool or as a blueprint for the program development. And even it can be used as a debugging tool. Now I will be explaining the signal flow graph considering one basic example of gun firing. In this gun firing, what will the main logic is, after counting for some particular seconds or based on a requirement, the bullet will be fired, and based on some, we will consider also the failure state. These will be the main states, and when we generate the signal flow graph, we will know various different states. First, I will now explain how the program is coded and what are the syntax which are followed. First, this diagram represents the directed graph. That is, from one state to another state, we were represented there will be a transition. It is a keyword, and we have to use this it is compulsory to use this same word. And this final state machine is just like a variable name or the program name. This subgraph once again forms the keyword, which is mandated to use the same word. And this subgraph represents the various states which come in the same line. There will be so many states. Whatever the states which are written in the subgraph will come in the same line, and the rest will be forming the other line. Once again, we need to note the important point is subgraph is a keyword, and we need to use the same word. And this cluster team leaders forms the variable name or the program name. It depends on the user intentions. This color, light gray, it represents which color the states has to be represented. Here we have used light gray. Depending upon the project use or the application use, the user can change this. This abort, fire and count are the various states which are there in this subgraph. And this shape is equal to circle means we are representing each state in the form of circle. That is, in the final state flow graph, every state will be represented in the form of circle. And coming out of this subgraph, this rank dir represents that all this will be in the form of horizontal. If it is not represented externally, then all this will come in vertical fashion. And this size is depending upon the dimension size. And now this starred count, these are all the things which are there in the left corner forms the various states, and the transition from each state to another state, and these are forms the input which causes for the which are the driving which can be referred as a driving force which causes to jump from one of the state to another state. In this similarly, after building it, similar to the C program, we will compile it, but instead of compiling here, we go it for layout, which generates signal flow graph, which is as shown here. Here we have seen this count, fired, and abort. This all forms the subgraph, and these all are in the same line. We'll maximize it, and these two are states, but this since we have not written it in the form of subgraph, they are given in separate. This line represents that this forms the subgraph. Now, at the initial state, the system starts at this start. Then the countdown happens. This countdown, depending upon the user requirement or application requirements, after the required number of count elapses, the system moves from the start state to the count state. At this state, two things can happen. One, if there is no user external interrupts, then it can go to fire state. If there are any external interrupts from the user or from the system, it can go to hold state. In hold state, it will be in idle state until any external interrupt is given. If an external interrupt is given, so the system will move back once again to the count state. And when the fire is happened, the system moves from the count state to the fire state. And one more thing is there is called a hang fire. This is whenever the malfunction of the system happens, then the system will goes to the abort state. And even if the fire, after completing that, it will go for abort state, and after all the operation is performed, the system gets reset, and once again it comes to the start state. This is one of the simple representation of signal flow graph. Now the one more application of this software is finite state machine, which will be explained by one of my teammate Gaurav. Thank you.
Okay, my name is Gaurav Nagare. Till now my friends Nikhil Mattani first of all, then Raunak Rathore, and then Nikhil MN, they all told you about first of all what is GVEdit, which is GraphVIZ editor, then how to work in that GVEdit, some basic example, then how to draw SFG, which is a state flow diagram. Now I am going to show you how to draw one simple DFG, means data flow diagram. Now here one system is shown in which one student is going through one quiz contest. In this quiz contest, the system is computer generated question, means computer generated questions will be asked by the system to the student. Okay, then first this student has to start the quiz. First of all, as you can see, I have already wrote the code and I have already executed the layout for this DFG. So I will just try to explain this one, this DFG diagram, how it is working here. Okay, first the student will initiate, means he will start the contest, the quiz contest. It will be like online contest, online quiz contest. Okay, then one first that system will generate one question as soon as the student starts the quiz contest. That question will be provided to student, then student will choose one answer and the system will record his answer. After this answer which has been recorded, the student is provided with one facility of changing the answer also. So that's why this in the square bracket is shown like a student answer. So it can the student, he will be shown his own answer what he has selected. Then that student answer will be gone to the system for evaluation after it receives confirmation from the student, or it may directly go for the evaluation if the student initially confirms that his answer is confirmed. Then the evaluate answer system will check with the correct answer from this square bracket, which is storing the correct answer. It will be compared with it, and then that response will be given to directly to the student. So the generate question state of the system is getting questions from one question bank which are initially stored in questions. So in this data flow diagram, first of all the data which is stored in the questions starts flowing from the questions bank, means question. So every square bracket in data flow diagram is storing some data. So initially this data is flowing from questions to generate question, and then to student, and then from student the data is flowing to record answer, and from record answer it is flowing to evaluate answer, and then after comparing the data is flowing back to student. In this way this data flow diagram works. So here in this GraphVIZ software I have used two subgraph. One subgraph for showing the system one, which depicts where this system is working. How is working means that system is generating some questions and it is recording answer and it is evaluating answer. These three jobs, these three functions are doing by the system, and three more elements are also there which are shown in system 2, but these elements has got one storage capacity, means this they will be storing the data in them. That's why they are shown in a shape of box. They are questions and then student answer and correct answer, and the student, which is the primary element of the of this DFG, is also having some data with him, and it will means he will be starting the data. That's why he is also the initiator, and that's why he is also shown in the square bracket. Okay, this is how the DFG works. Now we have completed the primary explanation of all the graphs and of all the basic functionalities of GraphVIZ software to draw the signal flow graphs and the data flow graphs. So thank you guys.